Hello, welcome back. So this is welcome to this is the third video of the series. So masih belum pasti lagi ada berapa banyak video yang saya kena buat. So in this video, we will discuss I will show you how to perform instruction execution cycle. Jadi basically in this video kita akan tengok yang ini lah. Instruction execution. So kalau di dalam buku kita tu dia in chapter 3. Chapter 3. Okay. Jadi before we go to the practical side, so let's just revisit introduction. Very brief introduction of this chapter, of this topic. So basically instruction cycle. Instruction cycle consists of two steps generally. The very basic instruction cycle consists of two steps. The first one is what we call as fetch cycle, and the second one is execute. So let's say we have an instruction to perform arithmetic operation. Let's say for example a equal to b plus c. A equal to b plus c. So the fetch cycle, in the fetch cycle, what we do is to fetch both operands from the memory. Ini kena ingat, semua data disimpan di dalam memory, tiada di dalam CPU. Jadi apa yang perlu kita buat before we execute any instructions, we must fetch all the operands, all the data, including the instruction itself, from the memory and send them to the CPU. Hantar balik ke CPU. Jadi in this case, let's say we have an instruction to perform arithmetic, which is a equal to b plus c. So the fetch cycle in this case, will fetch both b and c operands. So kita akan fetch operand b, b and c from the memory. From the memory, send them to the CPU. Kita akan hantar ke dalam CPU dan disimpan dalam register. So that is the fetch cycle. Once we have fetched all the operands, next is to execute. So the execute cycle will perform the add operation. The execute cycle will perform the add operation. The fetch cycle will fetch both operands, and the execute cycle will perform the add operation. So that's it. Itu dia punya basic introduction on instruction cycle. So this cycles will be repeated, until all instructions have been executed. Until all instructions have been executed. So untuk menjimatkan masa, kita akan terus pergi ke contoh yang kita buat dalam lecture, semasa lecture. So semasa lecture kita ada buat satu contoh, dan semasa tutorial pun kita ada buat. Tapi kita cuma tengok satu contoh yang kita telah buat dalam lecture. Dalam lecture kita ada instruction format. We have an instruction. So this is an instruction. So the format is, we have opcode and we have address. Okay, it consists of two fields, code and address. The opcode is bit 0 to bit 3 and the address is bit 4 to bit 15. So in total we have 16 bits instruction, and we have an integer, okay, where the most significant bit is the sign bit, okay, and this is the format of the integer, and the rest are the magnitude. Okay, and we have 3 opcodes. We have 3 registers and 3 opcodes. Okay, so the first register is PC, program counter, and then we have instruction register, and we have accumulator. These are the registers, and we have 3 opcodes, okay, which are 00 in binary representation, 001, 0010, 0101. So this is load, and this one is store, and the other one is to add. Okay, add. Now, so we have a series of instruction and operands, okay, operands which are already stored in the memory. Okay, so this is it. Okay, this is, okay, the memory. Okay, the memory. Right, 1, 2, 2, 3, blah blah blah, and there is another 2, blah blah. Okay, and we have 3 registers which are PC, IR, and EC. Okay, so the address of the memory is 300, 301, 302, 940, 941. Okay, and the content of the memory is, the first one is 1940, second one is 5941, third one is 2941. That is the instruction section. At the bottom we have the data section, integer section, and we have 2 integers which are 3 and 2. Di dalam memory kita ada 4 digit. Why? Because the instruction and integer format is 16 bit. Okay, 16 bits. So that means when we convert it to hexadecimal, we need 4 digits to represent those 16 bits. Okay, 4 bit for each hexadecimal value. And for our PC, and here we have the first one is PC. Okay, the program counter. Next we have IR. Okay, and then here we have the accumulator. Or the other way around, or doesn't matter. Okay, doesn't matter. Now we will start to do our instruction execution. Okay, you have to remember, for each instruction, as you can see, we have, in this example, we have 3 instructions. Okay, we have 3 instructions. The first instruction is this. Okay, this is the first instruction, followed by the second instruction. Okay, the first instruction, second instruction, and finally the third instruction. Okay, so the way the CPU execute the instructions is in a sequential manner. in which the CPU will execute the first instruction followed by the instruction adjacent to it, okay, next to it. So in this case, the CPU will execute the first instruction, which is 1940. Once the first instruction is executed, CPU will fetch and execute the second instruction, which is 5941, then followed by the last instruction, which is 2941. So and in that, what we will do in a moment, okay, in a couple of minutes. Ini yang kita akan buat sekejap lagi. Okay, so I think I'm gonna move that. Okay, undo. Okay, now we will go to the first step. Okay, step 1. Okay, step 1. So in your exam, if the questions, this type of questions occurs, okay? Kalau soalan macam ni keluar dalam exam, what I want you to do is to please precisely and clearly show the step-by-step stats of your memory and registers. Okay, minta tolong tunjukkan dengan jelas kandungan register dan memory untuk setiap step. So kita akan start with step 1. So basically, the odd steps is a fetch cycle. Okay, is fetch cycle, and the even steps are execute cycle. Jadi step 1 is fetch, which means CPU will fetch the first instruction from the memory. So just for you to remember, this is your CPU and this is your memory. Okay, ini memory. Jadi CPU akan fetch the first instruction and send it to CPU, store the instruction or operands in the register. Okay. Okay, so we will start the execution. So for step 1, the content of the PC, okay, the content of the PC should point to the first instruction address in the memory. So in this case, the content should be 300. Okay, since our first instruction is stored in memory address 300, which is this one. Alright. Next, what we do during the fetch cycle, once the PC will specify the first instruction address, then the CPU will go to the memory and go to that address, which is this one, and send the content of this address into IR, to instruction register. Alright, so dia akan hantar ke sini. Thus the content of IR need to be updated. So that's it. So that is for step 1, fetch cycle. Next, we will go to the second cycle. The next cycle, which is, okay, panggil dia step 2. Okay, step 2, which is to execute the instruction that we have fetched from the memory. Okay, so yang ini kita buang. Alright, so kita akan execute the first instruction, which is 1940. So as what have been shown in the previous slide, okay, in the previous paper, this is 1, okay, the opcode. Okay, the first digit is opcode. Okay, the first digit is opcode, and the next 3 digits in hexadecimal represents the address, memory address. Jadi 1 maksudnya load. So that means we will load an operand from memory into register, into AC. Okay, into AC. Jadi please refer to your book when you view this video. Minta tolong buka buku page 93 for the latest edition. Okay, Stallings. Alright, so kita akan execute this instruction. So the opcode is 1, which means we will load an operand from memory, but we must know the address of that memory, okay, of the operand that we want to fetch from memory. So in this case, the address is given in the following three digits. Oh, sorry. So the following 3 digits is here. Okay, it's here. Jadi kita akan pergi ke memory address 940 and load the content into AC 0003, and we have to update the content of PC. Okay, so now the content of PC, okay, by default the PC will be incremented by 1. Okay, (301). So that is your step 2. Okay, that is your step 2. Next, we go to step number 3. Next, we go to step number 3. We have to delete this. Sorry, I'm gonna take some time. Kita kena delete yang ni and this one as well. Okay. Okay. Now we go to step number 3. So step number 3, this is an odd step, so that means we are going to fetch another instruction, fetch cycle. So which instruction that will be fetched next? We look at our PC, kita tengok PC, so the content of our PC now is 301, so that means we will fetch this instruction into IR and send it to IR. Okay, so the content of IR has to be updated, need to be updated. Alright, so the new content of IR is 4941. That's it. Okay, that's it. That is step number 3, fetch cycle. Next, we will go to the next cycle, which is step number 4. Okay, so step number 4, which is to execute the instruction that we have in IR. Okay, and we have to execute the instruction in IR. So the opcode is 5. Alright, the opcode is 5. Okay, dia punya opcode 45. So we need to look at our opcode, list of opcode just now. So 5 is here. Okay, so we are going to perform arithmetic operation, which is add. Okay, so if you look at your book, so add operation is to add to AC from memory. So that means we will add, okay, we will add the content of memory of AC with the content of memory, okay, of a memory. So which memory location? 941. Kita akan tambah kandungan AC dengan operan yang disimpan di dalam memory. Jadi alamat operan kita di dalam memory adalah 941. So that means we will transfer this 941, okay, the content of 941 into AC, and add dan tambahkan kandungan 941 tadi dengan apa yang ada dalam AC. So sekarang ni dalam AC kita ada 0003 plus the content of 941, which is 2, equal to 5, hexadecimal. So you have to remember that this is hexadecimal. So we update the content of AC, sorry. Jadi sekarang AC kita akan tukar menjadi 0005, dan pada masa yang sama PC will be incremented. So tadi 301. So sekarang PC akan menjadi 302. So that's it, step number 4. Now we go to step number 5. Okay, step 5.